Neptune, the eighth planet of our solar system, has been a topic of some controversy concerning the issue of climate change. Climate denialists have been quoting that Neptune's atmospheric temperatures are increasing by an average of 0.3 degrees Celsius per decade, and extrapolating that to Earth's global warming patterns, basically saying that these warming patterns are normal given atmospheric warming on other planets.
The research, however, does not look directly at atmospheric temperature increase. Rather, it involves the luminosity cycling of the planet through phases of higher light emission and lower light emission on a 10-year basis.
Another fact is that there are no humans or any other detectable civilizations on Neptune at the present time. So, we would have to add in the effects of human industry on top of those data quoted in the research. The research on Neptune discusses the average luminosity, which has increased by approximately 0.3 candela in the past few years. But we want to know about the average temperature change.
To do this, we need to use an equation that gives luminosity as a function of temperature. That equation is L equals 4 pi r squared sigma t to the fourth. Here L is a luminosity, r is a planet's radius, in this case 2.5 times 10 to the 7th meters. Sigma is a Stefan-Boltzmann constant, and t is the temperature of the planet. Deriving this equation, we can find the infinitesimal change in luminosity with respect to the temperature. Written here is the equation. We can now multiply dt to both sides of the equation to obtain this equation. If we integrate along the intervals x equals t1 to x equals t2, we get this.
Using the fundamental theorem of calculus, we can simplify this equation to the following equation. Delta L is equal to 4 pi r squared sigma times t to the fourth power. Solving for delta t, we obtain this equation. Substituting in the numbers we already know, we can deduce that delta T is equal to 0.36 Kelvin, or 0.36 degrees Celsius.
Overlaying the IPCC statistic that Earth's atmospheric temperature is increasing at an estimated 0.2 degrees Celsius per decade due to human intervention on atmospheric processes, we see that if there are humans or a human-like civilization on Neptune, the global temperature increase per decade will be approximately 0.56 degrees Celsius. This value is significantly higher than the natural warming pattern.
Another fun fact: since the discovery of Neptune in 1846, the planet has only made one of its 165 Earth-year revolutions around the Sun. Furthermore, although discovered in 1846, Neptune wasn't studied extensively until the 1950s. So, really, we don't even have one Neptunian year's worth of climate data on the planet. The warming patterns on Neptune could represent seasonal changes in the global temperatures Neptune completes its year. This being said, we cannot look to outer space to help solve our global climate problems. We must look internally to determine the influences we have on our own atmosphere and act according to our findings. This was Cold Climate Files.